In this video, you'll see how to create AWS CloudFormation Registry resources. With this capability, you can create your own resource types for use in CloudFormation templates, share private resources with your account, and manage private resources using AWS config and drift detection. The CloudFormation Registry lists the resources available to your CloudFormation account for use in your stack templates. To get started, let's go to the registry. There are two types of CloudFormation Registry resources: public resources provided by AWS and private resources developed and registered for use in your account. This account has no private registry resources. To start defining a private resource, let's go to our development environment. We'll be using Cloud9, but all steps we take here can be done in a local development environment. First, we'll use pip to install the CloudFormation CLI tool and the Python plugin. Let's make sure the CloudFormation CLI tool installed properly. Next, we'll install the CloudFormation Serverless Application Model, or SAM, CLI tool, so that we'll be able to locally test and debug the Lambda functions containing the provisioning logic for our resource. Now we'll create a project folder for our resource type. Next, we'll run the cfn init command to bootstrap our project folder with all of the necessary files and folders for the creation of our resource. For the purposes of this example, we'll create a resource type to implement logic for the provisioning of a password policy resource. Let's implement the provisioning logic in Python 3.7. We'll follow the recommendation to use Docker for packaging the provisioning logic. Let's take a look at some of the files the wizard generated. Our folder now contains a JSON file that defines all of the parameters, resources utilized, and metadata for our new resource type. At the top, we can define our resource type name, description, source URL, and any schema definition metadata we choose to provide. Here, we can define any properties and parameters to be used in our handler logic. At the bottom, we see that a resource type implements provisioning logic for create, read, update, delete, and list events. Any necessary permissions for the AWS Identity and Access Management, or IAM role, to perform these tasks are defined here. The cfn init command also generated boilerplate source code for the handler logic. Let's take a look. This Python source code file contains handler logic for our resources create, update, delete, read, and list operations. The models file contains data structure definitions that will be used in our handler logic. It was generated automatically using the JSON file we saw earlier. Let's return to that file to add some custom fields for our password policy resource type. Let's clear the boilerplate definitions section. For our purposes, we'll define only the properties and necessary IAM execution policy for our resource type. Let's replace the properties section with the properties we wish to define. Under Required, we can specify whether any of our defined fields must be filled in when our resource is provisioned. Let's set minimum password length as a required field. We can also designate specific properties as read-only. Let's do so for the resource type name. Let's also designate the name as the primary identifier. In the handler section, we'll define any necessary IAM policies required by our resource type's corresponding IAM execution roles. Let's save the file and return to the terminal. Next, let's run cfn generate, which will automatically refresh our resource type data models and documentation with the fields we just defined. Let's look at the documentation. As you can see, the README file was automatically populated with the defined properties and values. It also auto-generated a description of each field we input, including links to more information. Similarly, the data models have been automatically generated according to our specifications. Next, we'll use the data models to provide the provisioning logic for each handler operation. First, we'll define the desired state of our create action using the getAccountPasswordPolicy model. This model returns the policy or raises an error if the policy isn't there or the action fails. Next, we'll implement the creation logic for our password policy resource type. We'll continue defining the logic for each of the handler functions. Let's run CFN generate to refresh our project files. Before submitting our resource to the directory, we can perform tests to ensure the handler functions work as expected. We can use SAM to instantiate a local Lambda function using our built resource type artifact and then run tests against it. In this case, we won't run tests. Let's submit our resource type to the CloudFormation Registry. Our custom resource type is now submitted and registered. Let's return to CloudFormation. Our resource now appears on the private resource type page in the CloudFormation Registry. A description, ARN, release date, and documentation are provided, along with the schema we defined. Notice that multiple versions of this private resource type can be created and offered for selection. Next, let's create a simple CloudFormation template that utilizes our new resource. Next, let's copy our CloudFormation template to an Amazon Simple Storage Service or Amazon S3 bucket and deploy it. We'll need to provide the S3 URL for the CloudFormation template we just created. Now that the resource is provisioned, let's navigate to IAM to ensure the password policy has been implemented in our account. The password policy has been added. You can see if configuration changes were made to your stack resources outside of CloudFormation by using the drift detection feature. In addition, resource types from the CloudFormation Registry are automatically tracked in AWS Config. With AWS Config, you can assess, audit, and evaluate the configurations of your application resources. You've just seen how to create AWS CloudFormation Registry resources. Thanks for watching. Now it's your turn to try.